Welcome to Thursday. Yes, I think it's Thursday. It's about 8 o'clock p.m. my time. It is very cold out there. And I'm going to just flip to my uncooperative browser here because it's always uncooperative. And it's not Dolphin. Let's do this one here. So you can see really cold. And it's supposed to get colder. What did they say for Friday here? This is all metric, so it's minus 16 Celsius with a wind chill in the morning of minus 39. And this is another 10 degrees on top of that. So if you're not aware, in Canada, Weather Canada changed the way they do wind chill. They used to do it, I believe it was minus 1 degree per 2 kilometers of wind or something like that. It used to be a long time ago. Now it's interpreted. So it feels like minus 39 out there. Your mileage will vary, but still darn tootin' cold. So I have been doing a lot with my 3D printer. I got into PETG now. Ooh. And I'm actually finding printing PETG is easier than printing PLA. PLA is I'm finding it very finicky to get adhesion. So I've been building these. So these are just little cutouts. They're like little models that you get. And what you do is you snap them all off. You put all the parts together. And in fact, it works like this. Lambda class shuttle from Star Wars, and there's little letters here, right? So they tell you which one's A, B, C, right? Somewhere's a D, D, E, F, G, H, I, J. So you put this all together, and you end up with a little model shuttle. I've been building them as Christmas gifts, but I went through the whole process of I rechanged my bed. So I was planning to do this. So I've done this method right here where you see that nut underneath and that bolt. So now I've tweaked it. And if I go to here, and we go to bed visualizer. Is it on this one? Yeah, so this is my new mesh map. As you can see, it's very, very flat. So before it was curvy, and as I said, right now I'm printing out this. This is the support arm for a C920-22-22X camera. So there's a bolt hole here. That's the standard. You put a metric bolt through there into the camera mount. And this clips to the side of the aluminum strut. So I had the C510, but C510 cameras don't have focusing, not even a manual focus. A C270 camera from Logitech, apparently you can do a hack to give you manual focus. So my picture was always blurry, so I took the camera off. So that is what I'm working on right this moment at the moment, printing that. So, and I actually went to Prusa and I bought more bed plates. And boy, that's handy having at least 2 smooth metal bed plates. Because as soon as you're done one of these things, for example, you take the bed plate off, you put another bed plate on, you get started right away. Right, on the next one. While this one cools down, because if you let it cool down, then these pop off real easily. So, but it's real finicky to getting these going. The initial lines it lays down on the first layer is very fine and intricate, and it's really easy to get a string or a blob or whatever. And if that happens, the rest of it won't work properly. But once you got past the first layer, no problem. So now, I did go and do a big buy from Adafruit. So I have a box down here that I am going to open up and have a look. So I'm just going to make sure that I actually have... Oops. Oh no, why is my base scene... Ah, there we go. Sorry about that. I was a little confused. I was looking at the wrong window here. So, we need our knife. And then I spent like a day, freaking day, looking for this bin with these lights. I thought this year I would get around. I've already, put this on. I figure I'd get around and I'd put on maybe some Christmas lights around here or something like that. I don't know. We'll have to see. So let's get the bubble wrap out of here. Lots of bubble wrap. Okay, what's in our bin here of goodies? Let's take the first bag out. So they finally had what Adafruit calls nudes, Noods. They're a type of LED in a very flexible thing. So this is what they look like. This is a nude. Whee! So I wonder if they mark each end. Nope, they don't. So white, 130 millimeter. This doesn't even look like 130 millimeters. So if we have 10, 20, 30. So here. If that's 1 centimeter, that's 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. If this is supposed to be 130 millimeter filament, that should be right here, according to this. So that's 13 centimeters down there. These are not inches. These are in centimeters. Because this is a metric pad, this thing. See, A4. This is definitely not 130 millimeters filament. Someone misbagged one. But this is a 300. So let's see what happens when we take it out. Now that's more closer to 130. But it's not 300 millimeters. Not even close. I think all of these guys are out. 300 millimeters, 30. So 10, 20, 30, 40, 50, 60, 70, 80, 90. That's 100 millimeters right there. Yes. I think they're too trusting. This is definitely not the 300 millimeters. So we have orange. And we have in here more colors. Yeah, these are definitely not 300 millimeters. I think they need to fix all their measuring on their bags. This is not 130 millimeters. Here, I got another ruler here. Inches, millimeters, 150. Well, maybe I'm wrong. Let me do another one here. This ruler has definitely got metric on it. So let's see if we got 130 in here. Okay, we do. From metal to metal. Sorry, I stand corrected. I thought these were in centimeters because this is a metric pad. Are you telling me these bottom map numbers are in imperial? Yep. The squares aren't, though. Squares are... No, they're in imperial, too. So, between two sets of lines, it's 5. This is 1, 2, 3, 4. This is 5 centimeters. I thought I had a metric pad. Oh, well. You learn something new every day. So these look yellow. They're not yellow. They're actually white. See? Warm white. It's weird. These are white. That's blue. These ones are pink. These are darker ones are red. So what else do we got in here? Oh yeah, a breakout box. I've been meaning to get one of these for cereal stuff. So this is a DB9 in here, and in here, well, is it screwed tight, or is it just clipped? It's just clipped. Whoa! I think we need the pokey tool. There we go. Breakout for cereal. I could take it out of the shell and just use it like this. Yeah. Now my usual procedure for stuff like this all the time is to get 2. So somewhere in here is another one. The free circuit playground. And what else do we got the free in here? Oh yeah, the free KB2040. By the way, they said they're running out of the pink version. So if you want pink, time to get it. So I Spy breakout board. This is for LCD screens. It's a way to get the ribbon cable from the I Spy port. So I have 4 of those. So these can all go in here. That can go in there. What else do we have? Another bag of goodies. Let's get another bag. Actually, I have under my feet. I have a bin for collecting Ziplocs and other stuff. So what do we have in here? Okay. INA 2A feather wing. I got this one for a reason. What's this one? Another one. And then we got 5 volt to 3 volt level shifter. Then we got PCA 9448 QT. Oh yeah, this is to get more stemma out of a stemma port. Like if you don't want a daisy chain, this will do that. Here's another one. Oh yeah, I thought these were real interesting. They finally came out with them. They're LED matrix backpacks, generic ones, so that you can just put any matrix you want on them. Now there were 2 types I think I got in here. These are without the I2C ports. I thought I got some with the I2Cs. Cowbell Proto. So this is a prototype thing for the Picos. So the idea behind this is you can put the pins on and all that, and you can put your Pico on here and have a kind of a breadboardy thing going. And this one, Cowbell Pico, Cowbell Pico, Cowbell Pico. This case I bought a few more. Stemma. Oh yeah, this is that big IR thing they're talking about. This is that high performance IR transmitter thingy. 2 different LEDs driven by a stemma. Yeah. And then this guy here is digital UV index, IR invisible. It's a different light sensor, basically. Bunch of stuff to put together. Okay. Of course, the free proto board. JS2PH2 pin breakout board. So this breaks out those stemma connectors, so that you can put them on breadboards. I thought that would be kind of useful around here. And what is this one? Adafruit SGB30 breakout. I think this is a gas sensor. Yeah, MOX gas sensor. This, I think, is it this one? There was a CS811 gas sensor I have. I lost one. I only have one left. And it was very, very popular, but the chip went out of production. I think maybe this one is its replacement. It's either this one or BMP388. One of these two, position L2, barometric pressure, temp sensor. No, not this one. Definitely not this one. Maybe this one. One of these two, I think I have two in here somewhere. One is a replacement. Now this, yes. This is the Adafruit USB and serial LCD backpack thingy. I'm surprised that there is this USB connector on it. I would think she would put a USB-C on here, but maybe this board hasn't been revised yet. Okay. I saw a really cool trick, a video on the net, how to make your 3D printer be a parts placing machine. And this guy was doing LED matrices, like little square ones, but yay big. You know, the ones you would see from Adafruit or something like that. So, okay, so these are the alphanumeric displays. These have more than 8 segments in them. I think they have 12. 14? Yeah, 14. So, and then this one is another one. And this, wow, RGB Smart NeoPixels. Oh yeah, I went and got a few of these little guys. You could put them on breadboards or something like that. I thought I wanted to play with some. I got too many stuff to play with anyway. So what's in here? Oh yes. There we go. So those other two were LCD backpacks, were a little different. This one here is the stemma version. See? But they have little stemma ports on them. QT14 segment. Yeah, more of them. So I bought a bunch of them. I saw someone do something really interesting. Instead of soldering the segments on here, they put little female headers on here instead, and then you just plug the segments in. So that's what I wanted to do. That's why I got a few empty segments too, because I had done all my previous ones. I would have to take some apart. Yes. Yes. Ooh, I got a lot of them. Maybe I will be taking some apart. Ooh. Okay. Adafruit bicolor 8x8 LED matrix backpack. Was this the one? Oh, this is just strictly the pinned one. Oh, I know this one. 1, 2, 3, 4, 5, 6, 7, 8x8. I got some of these around here. Yeah, I do. Okay. And then we got some more segment displays, some more segment displays. Actually, let us get the little bin out here. And these are occupying a lot of space, so I'm going to take these out of here. It gives more room for other stuff. Then we have here small 1.2 8 by 8 bicolor. Oh, they're for the thing. Okay, yeah. I know what this is. I have a bunch of these. So these are the ones from Adafruit, but these are a dime a dozen on AliExpress. And that's what those boards are for. Okay. Last bag. Oh, this is a big bag. Oh, right. So I misplaced these. These are the really, really good breadboards. Then I found them when I was looking for the Christmas lights. So now I have lots of them. But they're really slick and smooth insert and removal of stuff out of them. So, remember the other cereal? Here it is. So what do we got here? VL, a long distance checker. BMP 280? Is it BMT 280 is the other one? I don't know. Can't tell. Temporal pressure sensor. Okay. And this is PW. Oh, yeah. These are always so far out of back order, this one. I decided when they finally got in, I would get one of these PMW servo motor things later. Ah, yes. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So now I have quite the collection of, well, breadboards. Where can I put them? There we go. Oh, did I get 3 cereals? I must have. Okay. Okay, what else we got in here? Yeah, the flight and time distance thing. Battery chargers. And this was another BM280. Yeah, so battery chargers, distance. And then these guys here are the iSpy ribbon cables. And this one here, SGP40QT. I think this is another gas sensor. MOX gas sensor, yes. So these are the replacement. These both sets are the replacement for that CS811, I think it, or 711 or something like that. Now I thought these are kind of cute. IR. So I got that big IR projector. So these are pickups. Well, one's a pickup and one's a transmitter, I think. If I remember correctly. Yes. And then, as I said, ribbon cables for 18. This is just for doing his iSpy stuff. Now, I did pick up this. I was curious about it and wasn't really that expensive. Simon Monk. Electronics notebook. So this is what it is. So you can actually, it's a bunch of basic stuff on the back. Oh, it's kind of hard to see because of the brightness. Like that. There we go. So there's a bunch of stuff on the back. Bunch of stuff. Ow. On the back here. But the book really is a bunch of paper and Okay. And bill of lading. That can go in here. So all these. So you can actually stick it on things, or you can actually put this metal plate on like so. Whoops, a little dim again, isn't it? Let's turn it up again. Like so. So what you do is you go like this. And I got these guys. These are Liligo Mini D1 pluses. So I put the legs on these were okay, but they bend a pin? No, I keep forgetting that this is on here. So you have to do this closer to the edge. Like so. See how easy it just goes in? Right? And I think I have a pie around here, yeah. So, Pico, for example. And you can get it very easily out. Very, very nice. Way better than anything I've picked up from AliExpress. I don't think I have any as good in it from AliExpress as these. Also, like all of their design. Oops. Here's another one. If you do this sort of thing. There. Now you have a double board. You can also, if you don't put the metal plates, if I do the other one, what you could do is take this one off here, undo it, and take this one off here and undo it, and then you could put them together like that, so that it's 1, 2, 3, 4, and the power things are on the outside. Or you can leave one on and just have it in the center of power rail. You can also do it end to end like this, if you wish. Right, or this end. It doesn't really matter. But yeah, very nice. Oh, I was saving these silica gels because I didn't realize this. Do you want to know how much coverage one little pack of this does? It's huge. I found out that I have these big bagged ones, about yay big. They came from work, but they're designed to remove the moisture, or like a couple of cubic meters of space. So one of these guys here, probably you can do like probably a couple of these containers in size and dehumidify them just with one little one. Yes. Gives you no appreciation for those things. I was looking them up on a supply site. And you can get little containers with screw tops and all ventilated holes, and you buy this stuff by the bag load without the packet on it. Just the raw little pellets inside. And you'd fill these little containers up, and you can even print them out 3D wise. Right? Make your own little 3D containers to hold these little beads, and then what you do is you fill them up with the beads, maybe about 50% full, so they're a little bit loose, and you toss them into your filament bins. I thought that was kind of an interesting technique. So yeah, I could cut right here where the split is, for example, very carefully with a ruler and a knife, and I could take one of these off and join them together. So I think I'll leave this one out in the little metal plate. I'm just taking them out of their bags. Now I saw a question from someone on the video comments about they're trying out Platform IO and Visual Studio Code, and they gave up right away because of errors. Now, I did comment back to that person stating that sometimes when you first get started with that combination, since Platform IO is capable of handling, I think this days, last one I checked like a couple of weeks ago, like close to 1,200 controller boards in it. And they have what's called platforms, like frameworks, right? So you have to make sure that not only when you pick the board that you want to work with, that you have the correct framework in it. So we have I'm just going to put them in there. And all these guys can go into here. I don't think there's anything more in that box. Nope, there isn't. So I have the long ones here. And some more, another short one, and another 2 long ones. So, oh, another short one. I think I'll have to start a bin just for Adafruit breadboards. I already have a bin for breadboards, but I think I might either have to start another bin or just put labels on the backside saying these are actually Adafruit boards. Although it should be pretty easy to tell them apart because, well, guess what? They have very easy use. I have to change out some of my project stuff onto these guys there. They're really nice. Do. So I got I tried out a couple of these guys, these little chargers for these style about 16 340s. Yeah, they work pretty good. So you can put this is your what you're going to power up on it, and this is what you use to charge them with. And you have a little on-off switch on them too. And they're all rigged to, all regulated and charge themselves type idea. Like, I mean, control the charge. They even have, just like the bigger battery ones, they even have 3 volt here too, and 5 volt, 5 volt, 5 volt. So you can put pairs of pins in here on both sides, and then you have a little feed, so you can feed little things off without using the USB port. Oh, don't worry about the scratch marks on the mat. It's one of these self-healing mats. Over time, the scratch marks will fade out. That's why I got it, because you can do this on it, and it's not going to hurt the mat. Also, I find it pretty good on against static and stuff, too. Just watching my print job with what they call PETG code viewer. Here we go. All these guys can go down here into this. All these bags. I do save them. Sometimes I have a use for them. And as I said, they just go down here. And all these. So, well, that's interesting. 2 are a different color. So the new ones I bought are a little whiter. These are off-white. Doesn't matter. They are. A lot of times when you buy these things, they can come in slightly different colors. So, but it doesn't mean anything. It's not like the electrons flow any different between them. So we'll put those in there. This guy can go back over here where I had it. So let's see. Did I have Visual Studio Code up? Let's start. Not the Insiders Edition. Ooh, 173 came out. Which means extensions are needing to code. Of course. Because I didn't have Visual Studio Code up in the first time. Properties. Cody, where are you? Go. Console Visual Studio Code. There you go. There we go. So, let us find out. Installing. There was a change in Magic Python. The syntax highlighter, everything. And there's a line you have to put in. Let me get the device in question. I believe Microsoft themselves now, I'm not sure exactly what's happening, but I think they've actually incorporated Magic Python directly into the Studio Code stuff in the Python meta package, the one that Microsoft actually does. So when you look at these side ones here, you see Python's actually by Microsoft. Now go to Magic, no, that. It's around here somewhere. Magic Python. Magic Stack Inc. So you still can get it separate from them, right? But this guy here, I need to actually uninstall it. And if I search for Magic Python, there's an actual version here called 3.10. The reason for that is after you do your updates on some distros, you actually have Python 3.10. You don't actually have Python 3.9, 3.7 anymore. Those ones. So since KDE jumped from 2004 LTS to 2204 LTS, one of the things, of course, that updated was Python itself. Now, if we go to our console here, do I have the overall desk? Yeah, I do. Okay, so if we go here, Control R, pip, Control R. I usually have to do this frequently just to make sure, otherwise I get whines from being unplayed. And the other one is circ up, which is the Circuit Python updater. Okay, so both of them are good in place. So I have this board here. And I don't think I have. Do I have the extra cam? Properties. Yeah, that's good. So this board right here. So let me find an appropriate cable here to use. I found one. Yep. So we need this guy in here. Okay, we should get, there we go, CircuitPy. And I'm pretty sure it's number 2 because the macro pad is number 1. It was the first one installed. So we go down here. Yeah, Maker Nano, that's the one we want. So it's finished updating. So we were reloaded again. And we go up to code here, and we'll just open up that workspace that's on here. Now, make a note of the date. Now, this is something, the CircuitPython add-on from Joe. Sometimes it works, sometimes not. See, there's a yellow already up here. So usually what I do is I go into here, and we have 19, but see the 221130, 221130. It's correct there. And it's correct here. So where are my yellows coming from? Oh. There's a thing to rebuild the Intella index. Oh. Report missing imports. Technically, they're not missing. Sometimes, as I said, Visual Studio Code's IntelliSense or whatever doesn't update properly. So if we do circ up and we want to look at I think we just do an update -- all. So the bundle's getting updated locally here. I have this layout on my virtual machine over there on a laptop, so more or less the environments are identical unless I get behind in one particular machine and I forget to do updates. Come on, come on, come on, come on, there we go. Okay, so they're all up to date. So if we go, there was a way, it was a bundle, add bundle, and freeze. I think it was just list. No, what was it? Well, there are a couple of ways. ls -la media will m CircuitPy lib. Yeah. So there's the bundle. So there's that HTU31D, the thing it was complaining about, and there's adafruit GPS MPY. They are technically in there. So since this, I already did the update all. And I think if I do an install, it's just going to complain that I've already done it anyway. Warning: typing extensions is not a known. That's a new one. I've never seen that warning before. Well, I can tell you also the warnings have just disappeared out of CircuitPython. Sorry, out of, I think IntelliSense caught up finally. I don't have bus device. Am I needing that all of a sudden? No, it's already installed now. Okay. Maybe that was the missing piece out of it. That was fine. But there you go. Anyway, dates are up to date on both. And go. Now, this is the line I was telling you about. If we go Control C, for example, this just started recently, like the other day. See what happens to all the code in the complaint down here? Code.py is overriding the standard lib module code. So this little statement here just tells it stop doing this. Ignore it. So you can create a .pylance. I think it's a .pylance conf or something like that. And you can put these lines in here where you say report shadow imports equals false. You can actually list them all. I think I have a couple of projects in here where I have a long list of Pylance warnings that I'm taking out. Now I have the type checking off because if I turn this on, we get this. Right? Like so. So what we can do is, I believe, if we open the REPL, what was it? Import board print no, let me just go find the code chunk for that. It's just two lines. This is kind of dumb. It's dir, not print. Okay, so dir board. So there's all my pins. So it's complaining about GP0, but GP0 is there. So I'm not sure what's going on with that, why it's doing that. Because these four definitely exist. Like if I was to go like this. Interesting. What was that again? It was... No. Sorry. There. So... board. See, this has changed, right? What if I did bus? Bus IO. Okay, dot. Okay, so what we got here? Nope. So something has changed. Like, it doesn't think that board has that. Import board. Because all these boards have a pin template layout. I'm going to have to ask about this because this is stupid. Because I know the thing actually works. So if I go back GP0 here. And I go here. It was working over there. It should be working over here. Oh, right. I have bus IO. Thank you. There. See? Works just fine. But it complains about that. So, at the moment, I have this turned off. This part of Magic Python. So, I'm not sure what's going on with that. The other thing is, technically, I don't need Magic Python anywhere. There's this thing called, is it PyLint? No, Py something. It's this thing here. It's like out of Microsoft side of the world. So if you actually go to the plugin for Magic Python, See here. Attention VS Code users. Magic Python is used as a default Python highlighter in Circuit Breaker Design. Don't install it unless you want or need cutting edge version of it. You will likely see no difference because you're already using Magic Python. So, and in fact, I could go like this. I don't have it anymore down there, but it still works just fine. This is completely new to me. Like, I mean, I'm not sure when this actually changed. So, now one thing I have that floating around here. Yes, I do. So let's get out of this for a sec. Now I fixed also, by the way, my mag tag. I had to correct a couple of things in the code. The function name members, sorry, it's kind of like this stuff in here in this function. They changed the naming of it. One point it was max size or something like that, and then they changed it to scale. So everywhere I had those references where they had the old code, I had to correct it. So I got my mag tag back up running the weather again, but I had to change the code a bit. So we'll just get out of the REPL here. And we will safely close our workspace. And over here, we will safely exit that CircuitPython. Yes, if you just pull the plug on these, eventually you'll corrupt the file system in here. Simply because this storage that this stuff is on, this little tiny little drive, it's a FAT12 drive. And FAT12 does not take kindly for you to remove everything from underneath it while it has file handles open. So it's always a good idea to safely close things and then unplug things. Now this, I need the appropriate cable for this. And I think I have it down here. Yep, right here. So the question came up on the chat forum about, Platform IO and setting up code and going back to the Arduino IDE. So we have here the standard Uno. Old style, actually, with the chip in it. This is Sun Founders one. But it's basically the same. Right? What we're going to do is put the Blink program on here and go through a couple of tips on Platform IO to watch out for. So I don't need this, but I do want to check, did I create a projects directory for doing Arduino? Blah, blah, blah. Okay, so I created in here. I might have created on the VM, but not over here. So we have places, devices, search for. Yeah, we'll add to places. I always use that one, the ESP IDF. Don't use the Eclipse workspace anymore. Debs, controllers, code. Is it in code? No, we have some stuff. I don't really have a template in here anymore. MicroPython, Platform IO. So let's actually in here create a folder, and this will be just projects, and I'll add it to my places. But in projects, I will say Arduino. So we can create Arduino projects in here. So we need a Blink program. So since I happen to have all the I do have a projects folder. Arduino, Blink, and ESP material. Okay, so I do have one. Okay, if I do already have one, where is it? Where is this one? Oh, Platform IO projects. Arduino, Blinkit, ESP, Matrix. Okay, okay, that's fine. So do I have a Blinkit in here? Yeah, I do. So I do have a project, but we're going to borrow the Arduino project in here. No, we're going to borrow the code. Okay. So I should have somewhere the original Arduino code. So yeah, 81 examples. There we go. Basics. So here's our Blink program. Okay. This will keep this in mind. And I'll just move it out of the way for a sec. We come back here and we go to the Platform IO homepage, which is this little house right here. Okay, so when we look at things in here, boards, for example, yeah, 1,443 boards, right? And then you have what's called platforms. So you can see Atmel, AVR, Mega AVR, SAM, Expressive, Raspberry, STM32. So you have to get this right when you do it. So the best thing usually if you're dealing with an Arduino project, like an Uno, for example, is just to go and import when you say either new project or best just say import an Arduino project. So it will ask you where you want to put the project, right? So I happen to have, did I put work in here? In my places? Let's go find that again. Work. So we're going to put it in here. Oh, we need to choose an existing one. Right. Will and work. Arduino, and I have to go to examples, basic, Blink. Okay, so import. Oh, we have to select the board. I almost forgot about that. Uno. So we'll take a standard Arduino Uno. So by default, let me get the file explorer. So we happen to have it created this numbered folder right here. So in my regular projects, Platform IO, here, I should end up with a numbered directory, or I should end up with one back actually in Platform IO. So let me just find that numbered directory. Right there. Nope. Projects. Where did you put it? Okay, a sec. I have to find it. It's stuck it somewhere. And 2212. Okay. Search 2212. Okie dokie. Where did you put it? Definitely not in there. Definitely not in there. Didn't put it in here. Okay, this is funky. Where did it put it? Williams lost the file. It's got to be around here somewhere. Let's search from up here, from home. So we're searching for 221201. Well, this is strange. Normally, I would just find it right away in the Platform IO directory. Normally, it just should be in Platform IO. Right here. Okay, Will M, work, Platform IO projects. It should be there. Okay, bring the file manager up again. Man, I'm a bit rusty on this. Work. And what did they say? Work, Platform IO, yeah, projects. There should be a folder in there, and it's not showing up here. There we go. Okay, kitty. You're refreshing. It sucks. But anyway, back over to here. I'm just going to close this off. I'm going to move the folder. Oops. I have something open, don't I? Yeah, okay. We're just going to move the folder for close folder. Because I want to put it in. I'm kind of anal about this. I want to put it in a place I want to keep it. So we're going to cut. Where's our cut? There we are. And right here, Arduino, our test folder, paste one folder, and we'll rename it Blink. Okay. Ta-da. Now go back up to here, open folder, find it again, projects, no, where is it, work. Don't work. Projects. Open. Yes, I completely trust this author. I really wish that screen would go away. Okay, so this file here, the platform INI, this tells you what platform, what board, and what framework. These three are critical to getting it right. So you could change board, for example, to Mega, right? And you would have the Arduino Mega instead. It's actually not Mega, but you can actually add boards in here. So we could say, back to home, go to boards, and search Mega. So at Megas, right? 128, 1280s, right? So the 1280, for example, I believe that's the right one. Yeah, the 1280 is the bigger Arduino. So we could actually say we copy it and we can put it in here, right? And what you can do is you can do this sort of stuff. ENV colon end square bracket. So now we have another environment. This platform is also AT. Actually, as you can see, it could be that too. Okay, you can say board is equal to like so. Framework right? That sort of idea. When you do this and you save it, downstairs here where this default is, you now can pick 2 boards. So we can go and pick Uno. It sets it up for Uno. Now this is the bare minimum you have to do to get it going. So you're going to have in your source here the Blink IO. They fixed this, by the way. It used to be it didn't recognize the INOs quite correctly. You had to change them to CPP. Now, see this thing here? Doesn't know what this is? That's because, for some strange reason, you still have to do include. Whoops. You still have to include that. Now, you can rename this. There's nothing stopping you from doing that. You don't have to keep it as INO. In fact, all these Arduino code, all of it is underneath. It's all CPP. It's all C++. Right? But now we need to know, what port we're going to program this on and what it shows up to. So let's plug this in. So I've plugged it in. It's got a green light. And let me just get the cord out of the way. So I need to know what it is on. Okay? So, side note, if dmessage doesn't work for you, like it stopped working all of a sudden in Ubuntu, it's because of a security thing. If you edit this file in etc syscontrol.d, number 10, kernel hardening, and if you go down there, right there, and unremark this, you can also have this as a separate file. I did. So 10 local.conf. You can make your own up. The 10 simply means that it processes things with 10 before it processes things with 99. And you do this. Now dmessage is not restricted from regular people anymore. I know, it's annoying. But we plugged in, you can see down here, one Arduino, serial number, TTY ACM1. So we know where it is. Okay? Now, if we go back to Platform IO, notice there's no port in here. We can put that in there. Port. It doesn't know ACM1. I think that's what you need. You might need /dev/TTAUI. I can't remember. Try one. The other one you can do is, I believe there's something about serial speed. Well, there's TTY CCM1, but I think it's speed. And you could say 1 I think it's, no, 1 5, what's half? Okay, 32 7 68 65 535. What is 65 535 times 2? BC 65 535 times 2. No, 2400 4800 4800 times 2, 9600 times 2, 19200 times 2, 38400 times 2. Whoops. 38400 times 2. No, 48400 times 2. Let's get it right. 96800, 96800 times 2. No, 50. What's 50? Is it 57600? It's the next jump for baud rate. I think it is. There it is, 115,200. So that's a safe one to write to this thing at. Watch out! Don't make it so too. Whoops. 200. Watch out you don't write something faster. Let's go like this. So we'll see if our port works. We'll just build the file. Yes. Okay, so it's saying ignoring port and speed, so we don't got that correct. And I do have sample Arduino, so let me go find one here. Because I've done this before. So I should have a platform I/O here. Open with Notepad. Come on, Notepad. You can do it. I seem to be missing an editor here. System utilities. There, Notepad QQ. Remember choice all the time. There we go. There we go. So you can see in this one here, we actually have nano, uno, mega. So this, for example, is Control C. If we go to Platform I/O here, this is probably the better choice to use right there. Now there is a speed in that, so let me just go find the parameters for that. Platform I/O Arduino speed. This is what I'm looking at the moment, waiting for it to load. So we just need this. That's for the serial port. I think I got the wrong one here. Now port should be, because you can override the port. Upload port. There we go. Upload speed, upload port. I was close. Darn close. It was upload underscore port and upload underscore should be upload underscore speed. Yeah, we do need a dev. So this has to be dev like so. I mean, these are kind of optional, right? It already found the board. But if you're having errors where it spits out the thing, I can't communicate, double check that you got either A, way too fast of a baud rate by default, or B, that it can't find it properly. Like you might have multiple things. This is why I always go back to here, get out of the calculator, and do a D message and check here, this bottom block right there. So I know which thing it's on, right? Let's make sure I'm talking to it correctly. So it is blinking, by the way. See? So yeah, always check and you'll find it. So let's see if I can build again, because I changed some parameters in here. Let's see if I didn't break something. Nope. There it goes. Right? Da-da-da, da-da-da-da-da. Da-da-da. Oh yeah, we can always leave the terminal open, of course. There we go. So there you go. There, I mean, there's Blink. So then we can actually go and look at the Blink INO. Let's change Blink INO to CPP. Just for the heck of it, right? It used to be you would have to reload this file, but Visual Studio's got kind of good at it. It knows that you change things. So we know the blink. So let's change the delay to be shorter. And we'll rebuild it again. So it's on for a shorter span. Now, sometimes I found on some boards, this is in reverse. So let's change this to even a shorter delay. And we will just check again. But as you can see, it's no problem building. Just have to get things right. Doesn't seem to be changing that as quick as I expected it to be. Let's change this delay down to... It should go ding, 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 ding. So let's build a clean. It's actually C, so we have to remember that. Let's build it again, compiling everything. Blink isn't changing. Interesting. So, see this paragraph here about the pins? On the Uno, Mega, and Zero, it is attached to pin 13. So you could change this. Pin mode, LED built in. So you could say instead, we need to define a pin, right? You have to say, it already expands to 13, so it should be working. Now, I knew this sometimes... This is in reverse. Let's build again. And let's change the delay really big. And build again. It actually is not working. For some reason, the blink is not working on this one. Let us try a different board. I mean, it is compiling, it is uploading to it. So let's make sure here. So I have disengaged the board. See, USB disconnect. And I have another Uno here. So this is another clone Uno. Uses the modern Atmega, not this version, the dipped version. This is a what they call SODIMM 21, so something I can't remember. So we go demessage again. Now this one's on TTY USB 0. Now because of the platform I/O, I might have actually screwed up the port. So what I'm going to do here is change this to USB 0. I think it's USB 0. I said that right? Yeah. And we're going to slow it down to make sure. 57,600. And we'll clean the trash can, which means we make clean, and we'll build again. Yes, this changed. Okay. So if we go back to the code on here, and we'll change this. Now this is working. $100, Control S, build it again. I think I've screwed up with the terminal. Let me take this out. Feels like I'm not uploading properly to it. It feels to me that I'm not writing correctly to the Uno. I mean, I got the right stuff in here. Oh, William hasn't done this in so long, he forgot the other part of it. Yeah, so if you get this error, yeah, you got the wrong port. So, and I need this link. Copy. My UDEV rules are out of whack, so Control C. And I need a new set of rules. They provide one on their site that you might need. Yeah, there's a curl line that here you can do. So root cd etc udev rules.dlsmsle paste. Okay. Actually, I'm going to do it again. RM99 platform IO rules, and we will go get. There we go. Okay, so now we have a new set of rules. Okay. I must have not updated the rules in UDEV in a long time. So, since this is not on that, we're going to need this. Let's build again. No problem. Let's upload. Done. Now that's correct. Now we're blinking correctly. I kept forgetting to upload it. So this one probably, the other one probably works too. Now it's blinking correctly. Yes, even I have to refresh my knowledge. And I've been doing so much CircuitPython, I've forgotten how to do all this. But if you're getting that yellow message like this, and this is probably what's happening, where the port was not correct, you might have to put this in the thing. So let's do this again, just to show off the error. Warning. Oh, I did. I just updated my rules. Oh, I know what. I forgot. udev. Do I have one? Control R udev. It's like udev admin -- help. What we want to do is, I think it's like there's a udev restart, and this help is actually missing a parameter. udev admin restart rules. Yeah, okay. Something like this. Ta-da. Rules reloaded. So we can come here and try to upload again. Oh. You really insist me in doing it in here? Terminate task. Thank you. Just a sec. If all else fails, restart Visual Studio Code. Sometimes it doesn't pick up that you've updated things like that. So let's do it again. Control L, clear the buffer, rebuild everything again, and push. This is stupid. I have updated my rules. This is annoying me. Not this. The rules. Vine 99. Platform ID rules. See, I have another set of rules to cover everything basically plugged into the USB. That's that TTY rules. See? Wildcard. So RM99 platform rules. Control R curl. And greater than t.txt. Let's see what we actually get. Vi t.txt. Yeah, it's different. Okay. Move t.txt to, we want it as this. There. Okay. Vi 99 platform IO :0. Right, they're in. So Control R and udev min. Let's do this. So this here, that's wrong port. If you're getting that, that simply means you got the wrong port. You can get this out of Arduino IDE the same way, and it doesn't know where the port is if you didn't specify the port correctly. So since I obviously don't have the port specified correctly and I don't need home, I will unremend this line out again. Are we finished? Nope, we're still writing the printer. So, clean, sure, why not? Build, sure, why not? Push. Hey, rules are correct now. Ta-da. And you can see in here it's finding the port correctly now. User manually specified port. Ta-da. Okay. Just beware, some of the older Unos and stuff like that don't accept a speed higher than 57600, especially on Nanos. So if you've got one of these guys, for example, watch out. One of the differences between the old bootloader and the new bootloader is that serial speed. If the serial speed is wrong, you get the complaint from these guys you can't upload. These ones are more forgiving, these guys, or the Megas, right? But there you go. This is just how to do Arduinos. Now, there are other boards. Like, I mean, you can stick a whole ton of boards on here. As I said, 1200 and whatever it was. The thing. And this is also, see, I could change it to this and put the Mega on here and write the exact same Blink code to it. So let's file close this folder. Close folder. And we'll just unplug it. Now these guys, you can plug and unplug them all you want. You're not going to do anything because they don't have an SD card style or an SD-RAM style storage area like the CircuitPython ones do. Right? Yes, you cannot put CircuitPython on here. This is strictly Arduino. If you want to do CircuitPython but in an Arduino form factor, you're going to need... where did I put one of those? No, not that one. Ah, there it is. So one of these ones. So this is a Metro Express. It runs a, if I remember correctly, a SAMD21. Not the same as this. But this you can put CircuitPython on. Not a very big CircuitPython, but it has the same pinouts. Okay. Now this guy here is a little different than this, and this are the same right here, but this is where it's kind of you could put a Blackmagic or some sort of JTAG programmer or anything like that. You can put it on here, and you can actually what's the term? Oh, what the hell do they call that term when you do that to one of these things? If you brick one of these. Like, let's say you really screw up in programming one of these and it doesn't do anything anymore. Well, you can actually come back through here and unbrick it. Now, on these ones, you can actually use one Uno to fix another Uno. So you can make this, instead of being an Uno, it's a programmer, an Atmel programmer. And you would cross wire it to another. And I've done this before a couple of times to fix an Uno that I really screwed up. This one also has some other features on here, like DC jack that has an on-off switch. There's an onboard NeoPixel light So if we grab our other cable here, I think it's this one, and we were to plug this in, like so, we have a NeoPixel cycling through 4 colors. Now I'm not sure if this will come up with a, I don't know what mode I have this in. I might not have, I think this might be a new one, and I don't have it in CircuitPython mode. So if we do our D messages again, oh, we are having trouble with this device. So unable to enumerate USB device. Okay. There's the Metro boot right here. So what we're going to do is we're going to fix this right now. I probably haven't touched this in a long time. So delete this. And so if you on these particular Adafruit boards like this one, if you double click the reset button, you'll put it in the Metro bootloader mode, which allows you to update the UF2 file. And I suspect the UF2 file in here was especially old. So if I check my work directory here, I have a directory in here called controllers. And as you can see, I have a zillion of them here. So this is the Metro Express. I believe it's the M4 Express here. So my last one is 7.1, and I know we're at 7.3. So you go over to a web browser. I don't need that, and I don't need that. And we'll go over here, and we'll say Circuit Python. I think it's .org. Yeah, here. And we go to downloads. And what you do in here is you say Metro. Let's see if I can type Metro. So Metro M4. So is this a 0 or a 4? No, this is a 0. So over here on the file browser, I have in the wrong directory. We'll just back up one. We'll go into the 0. Yeah, I haven't done this in 0. So we don't have the M4 because there's no M4. There's no M4 written here. It's just Metro Express. So we don't have that one. What we do have is this one. This is exactly what we have. Now, the only difference, see, notice how this Atmel chip here is fairly big. This one's got the newer version. The sock is tinier. This is the revised Metro board. But it's still exactly the same. So download the UF2, controllers, and I think I better stretch this out. Metro 0, save the file. These are tiny files, by the way. We're talking like only a couple of K. 488K, right? So now I have that file. I copy it, and I go back. I've copied. I go back to the Metro boot, and I just paste it in here. It's done. It reboots. And it should come up. There we go. CircuitPython drive. So I know it's the second one. There's the Metro code. In fact, if I open this up with a notepad just to look at it. Look at the date. 2021, 12/17 was the last time this was updated. Now, if you want to play it safe with something like this, and it's so old and you haven't touched it, take this thing and the VS Code directories and just delete them. They can be rebuilt. Leave everything else alone. Just delete those two. Right? Now, since we updated to this, I'll bet you, or whatever's in our lib directory, and that is all very out of date. So let's find there. Here's one. So we've mounted it. So circ update -- all. Found 7 modules needing updates. Doink. There we go. Then we can go back to here and we say File, Open Folder. CircuitPython. We say Open. It will rebuild the bundle and everything. We have this problem here, of course. Right? So we're going to fix it by borrowing a file from another one. Did I write that down? I think it's going to be hash pi oh, what was it? Pi something. Not pi lint. Where is that other board? Did I have it here? Yes, I do. We'll be back to this in a sec. We'll just open this one up again. We haven't done anything on this anyway, so. But I did pull a no-no. I did open it up. So what we need here is to look at this code. I want this. Pi right. Okay. I want that line. Control C. I don't need you anymore. Go away. And safely remove. Take it off. Put this one on. Okay. Okay, let's just close code. Don't save. Code 2, code 1. Let's just open code again. There we go. That's fixed. Ta-da. But there you go. I mean, this there's CircuitPython on one of these. But you could program this as Arduino. It doesn't matter. This supports both mode and MicroPython. Also on here, you can do that one too. Right? Although the original Unos are strictly Arduino. So now this is all within this module. If we go File, Close Folder, you could go to Platform IO, and if we look in boards and we say Metro, there you go, Metros, M4, M0 Express right there. So you could add this into it. So that'll work also. And then you're, when you do this in this mode with this, you're doing Arduino framework and you're actually programming with Arduino. So then you would have to do Arduino stuff with it. But you can do that. Let's unplug it. So now setup of this has become fairly straightforward now. You should not have any issues. You just be able to put Visual Studio Code in. Doesn't matter the platform. You should be able to just install Platform IO. It just goes in. Everything's ready to go. You should see a little house down here at the bottom. And if you use their new project wizard or their import Arduino wizard, right? They even have project examples. Right? Whole bunch of them in here. By the way, Zephyr is a RTOS, real-time operating system driver. But there's STM stuff. There's another RTOS, the embedded. I have never messed with those, but there's all this Arduino, expressive, right? And they're so you see Atmel AVR, Atmel SAM. You would do this Blink program for the Metro. If you were doing the Uno, you would do this Blink program because this is an AVR. Or you just import from the Arduino IDE projects example directory, whatever project you want to do. Or you can just start one off by in Scratch, like saying new project, Arduino style, and pick the board and all that, and it'll create that platform IO platformio.conf for whatever, and you'll be fine. So if you have errors, it's most likely you got the wrong port or something like that, like I showed you. But let's see. Ooh, it's kind of a long recording today. So I'm on holidays, so I might be doing some more stuff. Ooh, the printer's done. Ooh. So if we go here and let's find our printer. It's around here somewhere. There it is. That's what we printed. So this clips onto the frame. This is the wire guide for the camera, and then the bolt hole for the camera itself. So I'm going to go and stick this camera on. Oh, and this is only showing 44. There's the finished one. 82 layers. And I did this all in PETG orange from Prusa. I picked some of that stuff up. Yeah, see, PETG. So we should be good to go with it. And I'm thinking I might print some more of these models out in PETG instead of Prusa. Sorry, instead of PLA. They seem to work better. But we'll see. And I guess I'll cut it short. And have a nice evening. Bye.